Hi, in this video I'm going to discuss assignment number 9. Let's start with question number 1. In question number 1 we are given with f and g and both are continuous at a point P. Okay. And we want to show that f plus g is also continuous. Okay. At P. So let's see. Okay. So since f has limit at P, I mean it's continuous, so it has a limit at point P, and that limit is fp. Okay, so this definition holds, right? For every epsilon greater than 0 there exists a delta 1 greater than 0, such that if this condition holds and x belongs to ab, then this condition holds, right? Similarly, this is also given that g is continuous at P, so g has limit at P, and that limit is gp. Okay. So this epsilon delta definition holds, right? For every epsilon 2 greater than 0, there exists a delta 2 greater than 0, such that if your x minus p is between 0 to delta 2, then gx minus gp is less than epsilon 2. Okay. Now, I want to show that fx plus gs has limit, and that limit at x at p, and that limit is equal to fp plus gp. Okay. Okay. How do I show that? Okay. So let's begin with an epsilon greater than 0. And okay. What I will do, since this one holds for every epsilon 1 greater than 0, and this one holds for every epsilon 2 greater than 0. In particular, I will choose epsilon by 2. Okay. In this definition, let's say this is 1 and this is 2. In 1 and 2, take epsilon 1 to be epsilon by 2 and epsilon 2 to be epsilon by 2. Both of them will be greater than 0 because epsilon is greater than 0. Okay. So this one will reduce to, there exists a delta 1 greater than 0, such that x minus p delta 1 0 also x belongs to ab. If this happens, then fx minus fp will be less than epsilon by 2. This one is your 1 star. Okay. And now 2 star will be similarly, there exists a delta 2 greater than 0, such that if your x satisfies this and x satisfies this, then gx minus gp is less than epsilon by 2. This is 2 star. Okay. Now let's see. Choose delta to be minimum of delta 1 and delta 2. Okay, this delta 1 and this delta 2, you choose them to be minimum of this. Okay. Okay, if you choose this, then delta 1 is also sorry, delta is greater than 0, because minimum of two positive quantity is positive. Okay, delta 1 and delta 2 are positive, so this one is also positive. That is clear, and it also satisfies this one. Okay, now check let's check if x minus p is less than delta and x belongs to a b. Okay, then your x belongs to p plus delta, p minus delta, and x not equal to p, this one. Okay, and this one is satisfied, right? Because using this one, if you use here, then you will get this. So your x belongs to, right, and x not equal to p. And this one will be, I can write it as x minus p. Okay. Similarly, okay. Uh, okay. Similarly, you can also check this one also holds true. Using this one. Okay. So as you will see, this one will reduce to this thing. Okay. I'm not writing this one. This one is common here. Okay. This x belongs to a comma b. Okay. So both of this are true. This one, let's say this is double tick and this is tick. These two. Okay. Both of these condition are true. If you take this delta. Okay. This delta. Uh, this one. Okay. If you take this delta, then because of this and this, and by calculation, I have shown that this one holds true and this one also holds true. And now we know that if your because of what is this tick and double tick, this one I showed you, right? This and this. Okay, so this one and this one holds true. So one star, this one is also true, this one is also true. Okay, so now I will use that. Okay, I wanted to show this, right? Use triangle inequality. So first club this two term. Use triangle inequality. Okay, triangle inequality is this one. Okay, so that one I'm using. Okay, so if you use this one, then from I am taking this from 1 star, this one, and 2 star. This both of this are true because these condition are satisfied. Okay, these condition are satisfied. Okay, I have shown that here. This and this, both of this are true. So in turn, we see that this is true and this is true. So I can use this is less than epsilon by 2 and this is epsilon. This is also less than epsilon by 2. So and this one is equal to epsilon. So I have shown that fx plus gx minus fp minus gp, this is less than epsilon. Okay, and I started out with taking this thing. If this one is true, if this one is true, if you take this delta, this, if you take this one, then this is true. So and so this limit extends to p fx plus gx is equal to fp plus gp, right? This is what we had to show. Hi, let's go to question number 1b. Okay, and we have to prove okay, we have to prove this integration of c fx is equal to c integration of fx. Okay, so let's begin. Okay, okay, and yes, what we are given is f is integrable. Okay, so let's first see that what we are given and what we need to prove. Okay, since okay, so I will write that given is f is integrable. You can check this f g b integrable function. Okay, so f is integrable. So what is this definition? So there exists I'm going to denote a b fx to be l. Okay, let's okay, so it is given f is integrable. So what does that mean? It means for every epsilon greater than 0, there exists delta greater than 0, such that if such that if you take any partition and the norm such that norm of p is less than delta, and this happens. You can take any ck between xk minus 1 to xk. Okay, we have a sum, right? F ck delta xk, k is equal to 1 to n, then minus L, this happens. Okay, where this one is maximum of delta xk, k is equal to 1 2 3 till n. Okay, uh, okay. So because f is integrable, we know this thing holds, right? What we need to show is that this one is given and need to show for every epsilon greater than 0, there exists delta greater than 0. Let me copy this. Okay. Okay, but this time instead of f, we have c into fx. Okay, so this should be okay. Then we say that actually, hmm, okay, if this happens, then we say that okay, and now you know L is this. This is what we want to prove. Okay, so I want to show this. Okay, so first, since I don't want to confuse you, so I will use this epsilon 1. Okay, and this will I will denote it by epsilon 1. Okay, so I have changed it to epsilon 1. Okay, I want to find a delta such that this thing I can make this thing true. Okay, so how do I go about it? Okay, well, let's replace this one also by delta 1 so that we don't confuse. Okay, okay. Let's call this 1. Okay, what we do, take epsilon 1 to be epsilon by mod c. Okay, then obviously it will be greater than 0 because epsilon is greater than 0 and mod c is greater than 0. Okay, if you choose this in equation 1, then obviously this thing will hold true, right? Fck delta xk minus L less than epsilon by mod C. Obviously, there will exist a delta 1 greater than 0 such that for all partition less than delta 1. Okay, I'm not writing p is equal to a and so on. So x0, this one, okay, and ck belongs to this. I'm not writing. Okay, so okay, because we put one in one we put epsilon by mod c. Okay, now you take mod c here, you will get, and then you can take c inside. Okay, and realize that I'm using here mod x into mod y is equal to xy mod. Okay, so I can take c inside. Okay, so that's what I'm using here. Okay, so can you now see that we have proven what we wanted to prove? Okay, okay. And what is the delta? Delta is obviously just delta 1. Okay, this delta 1. Okay, so this one is done. This one we wanted to prove, we actually have proven it. Okay, so this one is proven, but there is one note. Okay, that this proof fails when c is equal to 0. Why? Because let's see, why does it fails? Okay, uh, first of all, if c is equal to 0, then dividing by 0 won't make sense here, right? Right, that's the problem. Okay, if you take c is equal to 0, then it won't make sense here. Okay, so what do? You handle this proof is fine for let me make a remark. C is not equal to 0. Okay, then this proof is correct. So what do we do when c is equal to 0? We will do this. Mm, see, what we needed to prove here. You see, if c, if you take 0, then this one is integration of a to b 0 dx. Okay, so this one will be 0 and this one will be also 0, right? Because if you take c is equal to 0 here, then this one is 0. Now I will show that integration of ab 0 dx is equal to 0. Okay, how do I do that? See, I want to prove c fx dx is equal to c fx dx. This one is left hand side This one is right hand side, let's say. Um, so right hand side, obviously you will see 0 integration of a to b fx dx is equal to 0, right? I will show this is 0 multiplied by, okay. So now left hand side a to b 0 into fx dx. This one is a to b 0 dx. Now note that this 0 is different. This is not the number 0. This one is the 0 function. This is 0. This one is actually 0 function, which means it takes, let's say, any x from a to b, and it gives me 0. Okay, the number 0. You take any x from a to b, and it will give you it will return value 0. So this is actually function. Okay, let's say I will draw images. Let's say this is okay. So this one takes let's say any this one is the set, let's say AB. Okay, it takes any value between AB, and it goes and returns number 0. This is this 0 function. Okay, and what is the difference? When you usually write 0, normal 0, let's say, then it is a number, so don't confuse. Okay, here we are talking about the function 0. Okay, so to denote that, I will use maybe this one, dark 0. Okay, here it is the number 0. Here it is a 0 function. Okay, this is 0 and 2. Okay. So can you show that integration of 0 dx is equal to 0? Yes, you take any epsilon greater than 0. You take delta to be any number you like, let's say k. Then norm p less than delta, you take any partition. I'm not writing it. Ck you take between xk minus 1 xk. Then you see what will be the f c. Instead of f, we will have capital 0. Sorry, not capital 0. This function 0 minus 0. This we need to show is less than epsilon. Okay. But you see, since this is the 0 function, it will take any ck to 0, right? So this will be 0, summation of 0 minus 0 less than epsilon. So this is 0, which is anyway true. Okay, right? So right. So you have proven that integration of 0, this 0 function dx ab is equal to 0. This is the number 0. Okay, and that is what we wanted to prove, right? LHS and RHS are equal now. Okay, so this concludes question number 1. Thank you.